Testing 1 2 3，听到吗？
听到听到。
哦，那个 account 给那个 Mr. Leong 拿去用了，
哦，我奇怪什么叫 teacher home？
换名字了，改名换啊，搞不好啊要改名换姓啊。
这样子咩？啊，就改名字，改了个名字，运气比较好一点哦。
是，水还有肌肉，肌肉
哦，有趣咯哈，也觉得他其实是他已经知道了啦，但是他没有想到他的 physics 是这样子啦，不然他的 chemistry 他是知道是这样啊，
哦，已经知道死定了啊。
因为他 chemistry 睡觉嘛，不是我们不是有讲哦，他睡觉然后没有做到25题，然后25是 d 干嘛？
这么他这样的哦，他是搞什么啊？为什么会这样啊？
不懂哎，他就睡觉哦，我们全部都吓到哎，他有25题没有做到哎，40题的纸，他25题没有做到，
那他是我都不懂了，还有时间去教丢卷，搞什么鬼都不懂。
他很忙下哦，他很忙，他真的很忙。
是耶，哪里可以这样？真的是他以为他自己太得空了
我不懂他会不会拿前面。
啊，还要 drop 掉 Kimi 啊？
我不知道他会不会继续，因为他一直以来都是这样子，他 k 一直以来都是这样子的成绩，
嗯嗯
应该不会啦。他都来上补习了，应该不会不对吧？
，drop 掉不是说drop 掉就没有问题耶，drop 掉问题更大了，那你的 option 少掉，
嗯嗯，
少掉很多东西。
本来他是有他要的学校啦，还要去那个 Stanford 美国
啊，
啊，他去那个，
嗯嗯，是啊，Stanford 就去美国，那成绩要好，这样子
啊，
去，这样可以去。
嗯，
哎呀，我也是智商呢，
不懂哎，
怎么我是故意把爸爸放进来的，就以为他会讲啊，就
他爸爸是很看得开诶，什么都不
啊，
讲，他
谁
爸爸在当天就是 OK 重考，连跟他讨论都不要，他的爸爸，他爸
他爸爸
爸要他拿全 A 吗？不是，
他爸爸他爸爸都知道他的 trial 是匪楼了嘞，前
哈哈哈。
匪楼有 B 啊，已经是 big jump 了，哪里有这样的命？
他们家爸爸要他拿全 A。
他爸爸是这样子想啊，每个爸爸都这样想。以后你做
嗯
高说你也是想妈妈、爸爸，我儿子女儿要这样子啊，可是可以做
嗯，
到，不懂，不一定可以，
爸爸做么？爸爸老板啊，大老板。
应该是啊，应该是的。没有人来哦。啊，那个谁啊？
铁定啊，
啊，姐姐，
我不懂啊，他没有 message 我啊，我也不懂。
她已经很久没有来上课了，是吗？
嗯哼，
啊，又发生什么事情呢？这么好像你们很多灾难呢，
啊，
嗯，
我在，
多灾多难呢，不能发生什么事情？哎呀，这样讲开始，
可能等多一个5分钟哦。
可能是5分钟。
嗯，我问一下姐姐那个干嘛？
我也解决一下，看他是这么。
嗯，
这份有啊，印出来吗？
我用 iPad 啊。
嗯，可以可以。还是他们用错 link 跑去其他地方了？
啊，不是只有一个，另外一个那个都看得出是不可以用了吗？
哪里知道？
嗯，
嗯， 一年好，一年不好，一年好，够力吗？今年 coming 的 year 12啊，就很够力的，知道吗？我们很
哦，
厉，
是哦，哎，这
二三
是这么多
十，
straight A 嘞，很劲哎。
你们这边几个岁？
那时我们那年才6个吧，这
哼，
次20多个哎，开玩笑。
23个嘞，
嗯哦，
哇，差很远哦。
参员
哦，他们的
很厉害。
个90多、90多、90多嘞。
嗯，
嗯，
我看到。
所以这是一年好，一年不好，一年好哦，
嗯，
这么厉
好像那个，好像那个以前的那个 UBS 啊，这样一年
害。
拿，一年拿，一年拿。
呃呃，就是这样好笑的事情。嗯，非常好笑。刚他们那个补习班，我都看到啊，那个今年业绩好吧，没有缺课嘞，他们不缺
哎，
课了，
他们开始上没？
开始了啦，都开始2个月，7月开始，那第2个月了，
哦，
认真上课，不缺课，功课都
第三个也是有啊。
嗯没有这些，我这丢线的都是像个榜上的国中生，都是国中生
哦，国中生。
，IT 我还没有收到，IT 应该比较慢了，他们进
哎，
来的
我们有新生嘛？叶德定啊，
定怎么会有新生？不会有人，
梁董，那叶
我
创会，
嗯，叶超就有
叶创有没有外面来的学生？
有啊，有两三个啊，嗯，
来来，
很温，然后 Omega 啊到哪里？
哦，Oh my god，哦，Oh my god，
这你
哎，
发你的朋友啊，
我不懂啊，Oh my god 吗？可能呢，因为不很难讲哎，他们去年11月就毕业了哎。
嗯，喂，you are the only one，有来第三你先。
Hi, this Sam.
Father got met you or not? About how you try to track one. Oh, then now lecture can score at least a B. Other subject. Trial result. Do you remember your trial exam result? E for physics, actually not E for maths, E for maths. Then I think about C for history, then C for the physics is still B. Okay. So finally, what is your final decision? Saya only retain chemistry. Only retain chemistry. Because physics, I think I've been maintaining B for a long time, so I think just keep physics at B. Yes. And then maths, I think for A2 for score. So it's good. No, I only put chemistry on my own. Online chemistry teacher. Later, maybe you can recommend. Anything. Okay. Um, this kinetic theory of gases. So this is the thing you need to memorize. Okay. About this hmm? The notes. Did I give you the notes? You need to take notes. No, one big one. Same one. You. Okay, so this one, kinetic theory of gases, you need to remember there are six, 1, 2, 3, 4, 5. Okay, this one normally you need to write out at least three of them, the theory. Okay, first one is you have to remember they behave perfectly elastic. Okay, what's the meaning of perfectly elastic? I mean, when they collide with the wall, it will bounce back. Okay, when they collide with you, then bounce back will be minus u. That means you will not lose the kinetic energy. Okay, perfectly elastic. Second one is talking about the volume of the container is very big, and then the volume occupied by the particle is negligible. It means the size of particle is very small compared to the volume of the container. Okay, this is the second thing you need to know. The time between collision is negligible compared to the time between collision. The time of collision is negligible compared to time between collision means actually you have to use this thing to derive a formula. It means this thing you'll be moving in one dimension because the particle there are three dimensions, S, Y, and Z. So let's say they are moving in this direction. So when you collide with the wall, and it will bounce back. Okay. So when it's moving if it's moving, you'll be traveling with. It means you have to assume that it's moving in the container in the size of the cube size. It means all the length is the same. So that means you'll be making a round trip. That means before it collide with the wall, you'll be moving here, then collide. It means time of collision is talking about when it collide with the wall. Time between collision means it is the time taken for the particle to move in a round trip. So there are two distance. Time of round trip and the time of collision. That means when you collide, it's actually just for a while, but you need to make a comeback and then it will take a longer time to strike again. Okay, understand? Okay, this is the meaning of this. There is no attraction or repulsion between the particle. That means the particle when it's coming near to another particle, it will not cause the other particle to move. That means the particle, that means there will be no force of attraction. Okay. If you consider the force attraction means when this thing is moving, it will cause this one to go together. No force attraction. So this is the thing you need to remember. There will be no force attraction or repulsion between the particle, okay, when they are not colliding. Okay, last one is a particle in the random motion. Why are they emphasized on random motion? The meaning of random means you have to assume particle is moving in S, Y, and Z direction. That means there will be same amount of the particle moving in the same direction. That means they will divide by 3. If it's not random bias, maybe there will be more moving in one direction. Maybe there will be less moving in the other direction. But for these cases, when you're talking about random, means there will be same equal amount of particle moving in the certain direction. Okay, you understand the kinetic theory of gases? So this is the thing you need to remember. Okay, next one is you need to derive the gas equation. That means you need to derive this equation. Sometimes this equation is equal to this equation. Pressure equal to 1/3 rho. This one is called the mean square speed. Mean square speed. In the exam, to ask you about what is this. This one is an average value because mean tells us about average. This one actually means C1 square plus C2 square plus C3 square until Cn square divided by n. Okay, sometimes they'll need you to go and do some calculation. So this is the calculation that you need to know. Any question?
Okay.
Okay. Derivation for this. Okay, so first you have to think about a particle collide with the wall. Okay, normally we consider U. So when the particle bounce back, it will become minus U. So the mass of this particle is m. So this one will undergo change of momentum. So change of momentum will be mv minus u. So for this one will be minus u again. So it's going to be minus 2u. Okay, change of momentum. Okay, minus 2u. After that, you have to consider they are moving in the cube. So when they are moving in the cube, you start from somewhere coming back again. So when they make a comeback again, it means it's going there and then come back again. So the speed is equal to distance over time. So for this one, the round trip distance is 2L over T. You know why is it 2L? Because this one is, when we come start from here, go back again, 2 and 4 distance is 2L. So the time taken will be 2L over U. Okay. After that, you have to consider the force due to one. Force of one of them will be change of momentum. Okay, change of momentum for unit time. So the change of momentum will be 2mu. Just ignore the negative sign divided by time. So for this one, the time is 2L over U. So when you divide in this way, you give you mu square over L, mu square over L. But this one, the U, okay, after that you have to consider the average value. This particular, there are 3 directions. So there are 3 directions. It can be moving in S, in Y, and Z direction. So we assume that moving in the S direction is U. In the Y direction is V. In Z direction is W. So you make them UVW. So this UVW, the average value, I just have to remember the average, when they combine together. Oh, because of we had to remove the negative value. That is the no negative. UVW will be in this form. U, V, and W. So the resultant is actually this one, C. So this C things is actually equal to the U square, V square plus W square. So if you want to find the average, then become mean of U square plus mean of V square plus mean of W square. But because of random, then all these 3 things are the same. The U square is equal to V square and is equal to W square. So we can make it equal to this thing, U. When you have 3U, because all of them are U, you have 3U square. 3u squared. So this 3u squared will become 1/3 c squared. So this 1/3, when you put back to here again, you become the force will become m over l 1/3 c squared. And the force is actually due to the many particles. So we assume that there are n particles moving. N, so need to multiply by n. L 3 can put here, c squared. When you're talking about pressure, what is pressure? Pressure is force per unit area. Now the particle will be all colliding with this wall. When all of them colliding with this wall, the dimension of this wall is L and L. So it become L squared. So that means this equation become NM 3 L squared become L cubed C squared. So this is the total mass, and we can say that this is the total mass. And L cube is the volume. At the end of the day, it become the capital mass per unit volume times 3 c squared. So this one, mass over volume, is the density. Mass over volume become the density. So this one become the formula for pressure. So this is the gas pressure derivation. So in exam, they'll ask you about the derivation for this part. So, and then sometimes they'll ask you about what is N. Do you know what is N? N stands for the number of molecules. Okay, number of molecule. And the M stands for the mass of one molecule. This is a mass of one molecule. Mass of one molecule. Okay, mass of one molecule, the gas pressure. So can you see here? You say, I just want to highlight to you the important things. First, this is the time between collision, 2L over this. Then this is how we derive for rate of change of momentum. Then force per unit volume, all these things. And because of the random, so the S, Y, and Z, sometimes using U, V, and W and become 1/3. So the PV, this one taken from here because the L cube is also equal to V. So we have P equal to this one by right, you shouldn't use X, it should be XX. Okay, that's why here when I derive, I'm using the UV and W. UV and W. Okay, it'll be easier to differentiate because U is the speed of the particle in X direction, V is the speed of the particle in Y direction, and W is the speed of the particle in Z direction, the S, Y, and Z. Okay, and then this is the resultant. You know what is resultant speed? It means you have to combine them by vector way. This is considered the everything. So at the end, it will give you this formula. Any problem? No problem. Okay, so this is the thing you need to know. Okay.
Mr. Pang, can you zoom out the note just now you write?
Right one.
Okay. Okay, thank you.
So I send to the group. Eh, how to I can copy the number. Hey, DBH, how's the A level in some way? Can score or not? You can score. Just so one. Can physics can score. What do you get for physics? Not your best grade. So how you want to retake? Physics you got B. Oh, then how? Other subject? How? A little bit more to A. So you have to retake. When you retake, maths A. Then one A2 can push A. What is the best result for AS in some way? How many people straight A's? Got straight A? No A star one. AS no A star. Not many straight A's. Oh, very hard. Okay. Econs? You're taking econs. Why? Why you talk about econs? Okay. Okay. So these are important things that you need to know. Okay, derivation later we'll derive again. And then you need to know about this one is called the mean square speed. And then one more thing is called root mean square speed. Root mean square speed is mean square speed, just square root of root mean square speed. So in exam, they'll ask you what it is. You need to know this is called mean square speed. And what it is, this is a root mean square speed. Root mean square speed. There's a speed. Mean square, the unit, what is the unit of mean square? Mean square is meter per second square like that. So it's m square s minus 2. But for root mean square, the unit will back to ms minus 1. So mean square speed, mean square speed is different. Mean square speed is this one. Mean speed is just simply, when talking about mean speed, the mean speed is just the C1 plus C2 plus C3 up to Cn divided by n. This is called the mean speed. Okay. Mean square speed is different from mean speed. Okay. Okay, now any problem for this? No. Okay. Okay, let's see this again. This one is density 4.5 kg per meter cube. Pressure is the P 9.3 or 5 Pascal. Temperature 504 Kelvin. Determine the mean square speed at this number. Okay, the formula is pressure is 1/3 rho C squared. So we are looking for, but this is talking about temperature. Okay, there is another formula for this. half mc square equal to 3/2 kt. Okay. This one we will learn how to derive this one in future. K stands for Boltzmann constant. K, the value of K is 1.38 times to the power of minus 23. Let me check here. You know, this year, Austin best result in history. The result for IG and A2 and IG is the best in history. IG. A2, I think second best. But IG is the best in history.
In history?
In Austin Heights history. Oh,
Pretty good.
pretty good. That's why you all have to work harder. And we are counting on you for next year. No? Next year can, next year.
Yeah, but the amount of people more strictly because in UK some of the
Some people got late. Paper league. I don't know. Your paper is how about A2? Why A2 so many people score? And how do you explain that? Derivation. This one. Okay, we come back here again for this question. Okay, so for this one, what we have is this one. We are looking for C square. So if you want to get the C square, then you need to have C square will be 3 pressure over density. Okay, so 3 pressure over density. 3 times pressure actually is independent of the temperature because we don't have, we cannot use this equation because we need to know the mass of the particle. We use this. So you have to stick to this one. The pressure is 9.3 power 5 divided by the density 4.5. Then you can find the root mean square. What is root mean square speed? Root mean square speed is actually square root of c squared. Okay, square root of c squared. So can you get the value from the calculator? You get from here. Hmm? Just one. 790. Okay, right. 790 is answer. Okay, 790. 787.4, so it's 790 meter per second. Okay, the next one. Okay, next one is this one. We need to divide for the mean kinetic energy. Sometimes it's called mean kinetic. Here they use the word average kinetic energy. Okay, how do you divide this? This one you need to show that the mean kinetic energy. Normally you need to show the mean kinetic is equal to 3/2 kT. How to get this number? So first you need to know this one. Do you know this one? Yes, no. NKT. This one come from NRT. Have you seen this before? Yes, you missed so many lessons. That's why I don't know. The K is R over NA. Okay. So because this one number of mole is N over NA. N over NA. So when you substitute into here, you become N and A RT. N R over NA T. So this one change it to K. So you give you PV equal to NKT. PV equal NKT. So you need to use this one. This first equation to derive this one, to derive. So you start from P equal to 1 over 3 rho C squared. Rho C squared. Density, you need to change it to Nm over V. C squared. Okay, so this one, we can cross multiply. 3 PV is Nm C squared. 3 PV, right now. This one here, this one cross. Okay, Mn C squared. The mean kinetic energy is half mc squared. Okay, this is the mean kinetic energy. So we already have this part, correct? We have this part. This part, this part. So we need to make use of another equation. But PV is N KT, is it correct? So you don't see this thing first. That means we have equation 1 and equation 2. We can substitute 2 into 1. So PV replaced with NKT. So N and N cut. And then NC squared will be equal to 3 kT. Is it correct? But mean kinetic energy is what? Half mc squared. Is it correct? Can we say this is equal to this? Can. So is it half times 3 kT? Is it equal to 3/2 kT? Okay. In exam, they will be keep on asking you about this derivation. That means you need to practice to derive this from this and this and make it equal to this. Are you able to do it? Do you think you can do it? That's wrong. Cannot. Can you try to practice and see? You want to copy down? Derive yourself? Write one more time. Any problem? Seeing?
And
And, okay, so this is the one. That means you need to. Is it very distracting? Turn on the video. 不要开了. Distracting one. Okay. What? Derivation. Okay. How's your friend Tamido? Tamik, how Tamik?
Tamit say he going just go KL already leh.
It's because his grades are not very good.
So give out already left already.
He has to discuss with his parents first
Uh,
and then job the foundation.
go to foundation, should go lah. Always missing one, this guy. I didn't even see him at all.
He tells me it's very easy.
Lazy. Yeah. If he's too lazy, cannot study A level one. Lazy, only those who are hardworking can score well. Lazy people cannot do well one. Definitely cannot do. Better lah. I mean, wait, got grade or no grade? Ungraded. All ungraded.
He got 2E, 1 ungraded.
2E,
1D, 1D, 1
3 subject. So
Maths got D.
maths got D.
It's 56.
Uh,
Then it's chemistry got D.
uh,
40. Then it's bio engineering.
oh, okay.
At least maths can score.
At least maths can score. At least maths can still can score D. But no point one. D can do go. Cannot go anywhere. D can go. I'm not sure.
3 credit.
3 credit. C.
But Abir continuing eh.
Abil still continue. Abil
He
also
want to
he
take.
want.
then
Ah.
one thing, oh, two thing, one. Yeah.
Oh, why he stay? Because he want to pull the passing rate, is it? Pull the passing rate down. Aiyo, cannot. Cannot. Unless he change attitude, why cannot? Cannot change. Okay, okay, you just need to know this one. Other thing not important one, this one need to know. This formula, mean kinetic energy and this one. So here we got tell you about this thing. That means sometimes it's written this form. It means it's the root mean square. CRMS is directly proportional with square root t. Square root t. So that means kinetic energy depend on temperature. The higher the temperature, the faster it will move. Okay. That means if the temperature increase, then the thing will spin faster one. You'll move faster. Okay, we have for one example here. Helium treated as ideal gas. Helium behave root mean square of this at this. That means this is a C value, this is a temperature. So our equation will be, first we have to write down this one. After that, just put it equal to this. And after that, you have to write C square depend on T. Or C root mean square depend on square root T. So then you have to form two equations. C2 to C1 is equal to square root T2 to T1. Then after that, 5C2, C1 square root T2 over T1. Okay, one more time. First step, write out this equation. Very, very important. Second step, remove all this constant remove. Just a C square depend on T. Root mean square depend on square root T. After that, there are two cases here. This is the initial condition, and we are looking for final condition of the T, AT. So C2 over C1 is the square root of T2 to T1. Then after that, put in this value. This one stands for root mean square. Initially 730. Then square root. T2 is a final speed, but you cannot use Celsius. You must convert to Kelvin. Remember Kelvin. How to change to Kelvin? Yes, about 2 and 7.3. Let me check. I need to use 73.15. This one you have to use 273.15. So this one 80, you need to plus 273.15. Then divided by 45, also plus 273.15. Okay, so this one will give you 80 plus 273.15 divided by 45 plus 273.15. So give you how much? You get 769 or is equal to 770. Okay, so this answer. Okay, this answer. Okay, you can try the question now. Okay, try to answer the question.
You go to the next page because you can see the joints.
Drawing.
Second question. Or 1B, 1B.
1B.
This one is CK.
Okay, I see clearly. Okay, first question. Let's go through and see. So first one, correct or wrong? Are they equal? The time collision and time between collision. Negligible one. So this one cannot take. Mostly stationary. No, they are rolling randomly at high speed. So this one also wrong. Third one, are they identical, hard and elastic? Elastic, correct. Okay. Next one, correct or wrong? Significant or not significant? The volume of molecule,
Not CK.
not significant. So this one no wrong. So how about the next one?
This one correct.
Next one is correct. This one, correct also. This one also correct. This one, not correct. This one, correct. Okay. The rest are correct. The rest. Circle the one, the mean square speed. Which one is mean square speed?
Last one.
This one C. This one C. This one C. This one C. Mean square speed means this one right.
Yes. So that's one.
Last one. I think nobody will put like that. Wrong. The thing is not there. This one. This is a symbol for mean square speed. Like that. Okay. Yeah. What is the unit?
And 2S minus 2.
Yeah, M2S minus 2. M2S minus 2. Okay, root mean square speed. What is the formula for average means root mean square? Means this one. This is the root means average root mean square speed. CMS. So you need to square everything. Then divided by 1, 2, 3, 4, 5. Then you square root the whole thing. So what is the answer?
3, 4, and 4. 4.
350 square,
This one was,
356 square.
we don't actually have to square it.
Hmm?
We don't, I don't think we have to square it. Because plus 10 divided by 5. So that's the answer.
Different. You can check, is it? So
If you take the minus to plus.
okay, you see, now if you go and square everything, 346 square, 351 square, 339 square, then divided by 5, then square root. Okay, this one you are going to get 348. You're going to get about 348 meter per second. But if you go and do it like that, if you go and sum up, and then you go and divided by 5, then what is called average speed? Are they the same? They are not the same. This one there's a minus, so you cancel one. So it's different. You cannot jump step. You cannot say, oh, I want to straight away class together divided by, at the end you get wrong thing. This is different. Okay, state kinetic gas equation. Do you know what equation to give here? Can you look for this?
P,
P what?
P, 1, 3,
Pi over 3 nm c squared. This is the kinetic gas equation. Okay, kinetic gas equation. Okay, can you do this? Volume 20. Mole 6. Temperature 38. Mean kinetic energy. What it is? Mean kinetic energy is 3/2 kT. So this one, the equation that we have is PV and RT. You can also change it to PV and KT. So this one you can be found, right? It means KT will be also equivalent to PV over N. Then you sub into here. The problem is how to find the N. N will be N multiplied by NA, our Avogadro number. So it means the mean kinetic energy will be 3 multiplied by PV over N, or 3 PV N times NA. They'll get the answer from it. Let's see. Okay. So actually we cannot get the answer from here. The
no,
actually already can get from here. Okay.
so,
Yeah, correct. But this is average kinetic energy of the particle. Okay. I think we cannot use this one to get the answer. Okay. So mean kinetic energy for one molecule, this is for one molecule. 3/2, K value is 1.38 times 10 to the power of minus 23. Then temperature is 38 plus 273.15. Three over two times 1.38 to the power of minus 23 times 38 plus 273.15. So answer is 6.44 times 10 to the power of 21 joule. Mean average kinetic energy of the particle. Yeah, correct. Okay, so sorry, this one no use one. The important thing is just this one and this one. This one because we do not have volume, so cannot use this. Then what is the point of giving the this and this? volume. Pressure is not given. No point. Yeah. That means the other thing they are given on is actually the misleading thing. They try to mislead you. So these two things are not useful to us. Just this one. Okay. Can you try to fill in the blank for this?
Higher temperature implies more average speed and therefore higher voltage.
Yeah. Higher temperature. So higher temperature implies more kinetic energy. Means more average speed, more higher kinetic energy. Okay, this causes an increase in the
Force transfer to the walls from
momentum transfer to the wall from the more frequent collision. The increase in force per collision lead to increase in pressure. Increase in force leads to increase in the pressure. Force and pressure. Okay, one more time. First one, because we have the ideal gas equation half mc squared 3/2 kT. It means this one related to this one. When the temperature increase, speed will increase. So kinetic energy will also increase. And then one more thing you need to know is about the pressure is force per unit area. More force, more pressure. Okay, what type of collision is it assumed between the molecule and the wall of the container? It is elastic collision. I have to write down elastic. Perfect elastic collision. Okay. Okay. Okay, number 3, can you try to answer? Can you try to answer this? Identify by adding the indicated letter to indicate the correct arrow or the diagram. The L, where is the L? L is the length of the cube. Where is the C? C is the speed of the particle. Okay. And then the steps. Do you remember the step? Which one is correct for the time between collision? What is C? C stands for what?
speed.
Is it speed of light?
C is the speed. Oh, C. So is the speed.
Huh? Specific capacity?
It's
Latent heat? Are you sure?
that speed one.
This is the kinetic theory of gases. Just how when I derive the C, I will tell you about C, right? What is C?
Speed of the what is that?
This is still a gas particle. So cannot be this one, you're wrong. Is it speed of light? No. Is the time between collision equal to this? Is it this one? Oh. This one like that. What is V equal to distance over time, right? C equal to what? L, go and back, round trip. This is called round trip. How much is a round trip? 2L is called round trip divided by time. So what is time? 2 times length divided by speed of the particle. Is this one correct or not? Yes. Time between the collision, distance over speed. Correct or not? Distance over speed, right? Correct. The time travel, is it multiply? Time or divide? Divide. So this one wrong. This one is not speed of light. This one correct. C is not speed of light. C is the speed of the particle. C is the speed of the particle. Okay. Okay. Okay, try the next question. Okay, I'll let you try first. C and D, and later discuss answer together. Let you do. Okay. Okay, are you ready? Okay, pressure defined by what? Force per what? Okay, one person answer one question. This one first.
Yeah.
Force per unit area, correct. Second one, pressure exerted by one what? Molecule and what? Exerted by one molecules. This is the pressure executed by one molecule. The area, correct? Area. Okay. Zinc. Number 2.
Large number.
Oh, you very good. Each particle has different what?
Speed.
Hmm?
Speed.
Speed. What is the other one for speed?
Velocity.
Velocity. Because got direction one. They contribute to this. What is this?
Mean.
Yeah. Mean square speed. Okay, this one. This is the mean square speed. Very good. 3 steps to derive this one. State the dimension the molecule is moving in. What dimension? Dimension. This one. What is the dimension of this thing?
3D.
Huh?
3.
Number of dimension means LLL, L cube. 3 dimension, yeah, 3 dimension, right? 3 dimension. 3 dimension. Volume is L cube. Density. What is the formula for density? Mass over volume. What is the total mass? How do you write total mass? DH, how do you write the total mass? N times what?
N times M.
Over
3 liter cube.
V. Okay?
V.
V.
Okay.
Okay, good. Can you find the temperature? Number of mole. Pressure, volume. K. No, T. DH, how to answer this? What formula that shall be applied? PV equal to nRT. Okay, find the T lah, find the T. Pressure 5.6. Volume 3.8. And number of mole. R 8.31. Give me the answer. Please give me the answer.
$500.
500. Let me check. Yeah, 500 Kelvin. Okay, this one. How do we show the new volume? Average kinetic energy given by this. K is the thermodynamic temperature. Gas heated at the constant pressure. Temperature rises by this. Find the new volume. Constant pressure. That means the volume depends on temperature. V2, V1, T2, T1. V2, T2, T1, V1. What is the temperature? Initial temperature 500 increased by 125 divided by, yes, Jason, what are you doing? Where are you now? 125 divided by original 500. Volume, initial volume. Minimum volume is 3.8 times to the power minus 2. So what is the new volume? $500 plus 125 divided by 500 times 3.8 to the power of minus 2. Is it correct?
4.8
Set 5.
7.5. Yeah.
0.75 minus 2 meter cube. Okay, find the increase in the internal energy by using this formula. Can you give me the increase? How much is the increase? So let's see who can do it. You increase by how much? And explain your answer. Okay, this one there's one more thing. The mean kinetic energy is 3/2 kT. Increase internal energy, the U is actually the number of particles times 3/2 kT. Because cannot be in the gas, just one particle. Because this one just for one particle. So this U is for many particles. Many particles. And the N is also equal to number of mole times Na. So this one we can change it to N times Na times 3/2 kT. Okay,
What's the change?
that is 0.0475. Answer is 79. Answer is 7980. Very big difference. Not same. The increase in internal energy is due to increase in temperature. Can you try to use this formula to get the answer? Can or not? Try to work out yourself. Okay, no. The number of mole 5.12. Then this is Avogadro number 6.02, 23, 3/2, the Boltzmann constant minus 23, multiplied by, what is the change in temperature? The change in temperature is 125. Can you get this number? 7980. This one. Okay, what is the answer? 7980.
And A is always Avogadro constant.
It is always Avogadro constant. It's a constant, so constant cannot change. It's always the same number. Use the information to calculate the external work done. Okay, work done by the gas during expansion. The work done, there is a formula for work done, P delta V. Because during expansion will be work done against atmospheric pressure. So do we have the pressure, atmospheric pressure? Okay, this is a pressure. Pressure, I didn't say this is atmospheric pressure, just the pressure. Can we use this number? On part C1. Oh, there is nothing else to use. So you have to use this pressure. Okay, this is a work done formula. Pressure times change in volume. You know the pressure of the gas. We know the pressure of gas is this number, 5.6 times 10 to the power of 5. Change in volume. This is a final volume. And there is an initial volume. So the increase in volume is V2 minus V1. Is V2 more than V1? Yes, V2 is more than V1. So how much is it now? 5.6 to the power of 5 times 4.75 minus 3.8 to the power of minus 2. 4.75 times minus 3.8 times 1 to the power of minus 2 times 5.6 to the power of 5. Okay, this is, you're going to get this number. Is it correct? Okay, can use the first law of thermodynamics, determine the total energy transfer to the gas and explain your reasoning. First law of thermodynamics is like this. First law of thermodynamics tell you about increased internal energy equal to the heat supply to the gas plus work done on the gas. Okay, this one is called first law of thermodynamics. Increase internal energy. Do we know the increase internal energy? This is one. This one. And then this one. This one is expansion. So this is work done by. There is another formula. The work done on is negative work done by. So when you come back to here, when work done by is this number, work done on will be negative of this number. Is that clear? When you apply this, you need to change the work done by to work done on by using this relationship. Yeah. So increase internal energy is equivalent to this number. Increase U is the internal energy. So this is the 7980. The heat supply, this one stands for heat supply to the system. Heat supply. Q stands for what? Q stands for heat supply. And then work done on is a negative value. Can you find the heat supply to the system? So I need to take this plus this. 13300. So this is 7980 plus 5320 13300. Are you clear with this? This one we will study this again in the next chapter. First law of thermodynamics. Okay. How many things that you can write? What is P? P stands for what? P stands for pressure. Pressure of the gas. Don't just write pressure. It's the pressure of the gas. What is V? Volume of the gas. Meaning of is simple. Okay, so need to write everything. V stands for volume of the gas. N stands for number of gas particle or number of molecule in the gas. Number of molecules in the gas. M stands for mass of one molecule in the gas. Mass of one molecule. One is important. One molecule in the gas. C square stands for what? Mean square speed of gas. Mean square speed of the gas. Mean square speed. Mean square speed of the gas. Okay, that's all. Okay, any other thing? Can you derive this formula? Do you know how to derive this? Okay. Can you derive yourself? I want to see how you derive. Z, I want to see your answer. Can you send it to me, to the group? I want to see how you derive this. Please try to derive yourself. The rest of you also need to try. Please try to give me the answer. Can derive. Okay, give you some clue. The first one, you need to write PV and KT. And then
Yeah, I sent WhatsApp already.
I see Ziying so good. Let me see. Oh, you see? Very good. Let's see together. Okay, so this is one PV half CMC square. Oh, yeah, correct. Okay, So this one first, this one, put inside, divide. You see mathematics so good. Okay. Just do like that. Then you can score very well in the exam. Who said cannot do? Can do one. Is it A2? Is it very tough? Is it tougher than?
Okay.
Okay. Very easier.
S.
Yeah. Okay. This one, do you know what to do? Determine this. Mass of this is this. Determine the mean square speed at this. Assume this. We need to use this half mc square equal to 3/2 kT. Try to use this and give me the answer. Rearrange this one. C squared is 3 kT over m.
Zero 510.
511. Can you get 511? This one, the 20 degree, need to change it to Kelvin scale. Five one one. Okay, 511. Unit is meter per second. Mean square speed. Divided per second. Okay, Nazim. Okay, good. This one is the initial P. Got one piston, cylinder, hydrogen, temperature. After that, you need to gas particle, thermal equilibrium, emission temperature. The gas decompress. Sketch a graph of the this and this. Speed and the temperature decreases. Speed and pressure. Temperature depends on what? This one depends on what? C squared depends on what? C squared, normally I write like that one. Half C squared equal to 3/2 kT. After that, you need to write out the relationship between this and this, right? What is the relationship between them? kT. Does the temperature change or not? What is the minimum of thermal equilibrium?
The
The remain thermal equilibrium means temperature no change. No change in temperature. If no change in temperature means U doesn't change. T no change. T constant, so U is also constant. If T is constant, U will be constant. What does it mean if U is constant? Doesn't change. How do you show doesn't change? How do you draw? Arc, straight line, vertical line like that means always U. Same. Like that. Right? Who left already? What about this? Fixed mass. Temperature 24. Find the N. PV and RT. What is N? PV over RT. What is PV over RT? Pressure 2.1. Volume 3.3. R is 3. What is 3.81? 8.31. 3.81. 8.31. R is 8.31. Temperature convert to Kelvin. 273.15. So what is the final answer? How's Shah's? Shah's okay or not? Huh? Street B.
No, just got 3B, 1C.
1C. C
Ah.
what? C.
C, I think chemistry. I don't know. I forgot already.
Oh, still bio.
Oh, bio.
So sad. So sad. So sad.
0.28.
0.28. What about this? The mass of one molecule is this. Find the root mean square. What is the equation for mean kinetic energy? 3/2 kT. Are we able to use this formula with the number of mole? Is it useful to us? kT. Temperature, no. Okay, no. Okay, what is the answer? Try to use this formula and give me the answer. Please try to give me the answer. What will be the answer? Oh, my friend from Penang congratulate me. Because I post on Facebook and then they congratulate me. They say the top school in Penang also lose to us. The top school in IG. Top school in Penang, the best result is 16A only. Yeah.
Last year, our
7, I say.
7,
Straight A is only 7. This year is straight A's or 23.
23 straight A.
23 straight A's. That's why I can come up with this paper. Right?
So many.
So many. You know, real school got how many? 7.
7 straight.
Straight A's. Our is 23.
How many students was
Real school got about 700.
like our year?
Our year 11, our years got about 90 over 97.
Like 1/3 students got.
Yeah. Hey, you all really have to buck up work harder Walao you all see the year 13 can perform, year 11 perform, year 12 mind. All mind every day mind Huh?
It's a paper fault, teacher. Paper fault.
Paper where got paper fault. The moment I see you all in the A-level hub play game sleeping I know already. Every day I will go there still got some people sleeping one no studying one or play iPad. I know already. From the day I know already. I know this time I always tell other teacher the mistress this batch control like that. Sure control. I say let them control so that they can wake up. Control first let them control first then they'll realize cannot already. Friend everything is the same. All the best teacher teaching. Somewhat like that.
Teacher, next year you will be on
No, I won't.
No. So it's again,
Very likely. I'm not sure. I think so. C squared 3kt over m. Then square root mean square CRMS square root 3kt over m. 3k. K stands for 1.38 minus 23. Temperature 24. 273 by 15. Then the U is you can get the value from the calculator. U is 1.66 times 10 to the power minus 27. You know where to look for this value? Data sheet also have this value. Data sheet have. If data sheet don't have this, you can check in the calculator. There is a constant value option. Let me see the option thing. Where's the constant already? Constant. Look for the, this is the atomic and nuclear.
physics,
Yeah.
field cycle,
Where is it? You got U inside.
shift constant and fall. Shift constant and fall.
Shift constant for.
Shift constant and fall. Cycle and then plus one.
Oh. A long time. Cycle can be seen. Okay. So what is this number? What is the value?
500.
500. 497. Is it 497?
Yes.
Okay.
Yes.
Unit meter per second. Okay, the temperature, how? Increase like this much means C square T. C square root T. C2, C1 square root T2, T1. Oh, what is the ratio? This one is this one. What is initial? Initial 24. Change to Kelvin. Do the calculation. Give me the answer. Change to Kelvin.
No point. 0.8.
0.9. Is it correct? This one is you have to take the initial number is 24.
Yes, it increased by 70.
No. 24 plus 32 plus 273.15. Then divided by 24 plus 273.15. So what is the answer again? 0.8. Why different? 24 plus
Oh,
72 plus 273.15 divided by 24 plus 273.15 and square root the number.
24 degrees. Then what is supposed to be about?
Increase. No, this is the, oh, this is original. Oh, so this is the C1 to C2, eh?
Yeah.
So it's 1/2 number. Hey, what's wrong again? Again, sorry, let me check again. Original and new. Increases. Original. Original is 24 plus 273. 297. Kelvin. T2 is 297 plus 72. So 297 plus 72 is 97 plus 72, 369. So the original is 1, 2. So square root T1 to T2. Two nine seven over 369. 297 divided by 369 square root 0.8971 or 0.871. Okay, 0.897. Is it this number? Wait, oh, yeah, 0.897. Okay, if I include 1.5, then what happens?
Is it
297.15 divided by 369.15 square root. Yeah, same. Okay. Two assumption. Can you write out two or not? What are the two assumptions? This one. Two assumptions.
uh,
How many you remember? Just give me two.
the volume of the gas? That's like the
What?
time of collision is negligible to the time before collision.
Talk before. Between two collision. Between collision.
Then the
Between the collision. Okay.
force of attraction or repulsion.
Yes, correct. Okay, good. At least two lah. At least two or three that you need to know. Somehow you can write about elastic collision. Or Confining elastic. Okay. Use the kinetic model of gases, and this one explain the gas as exert the pressure on the container. How come there is a gas pressure? Why? No. This one you need to explain using the words.
Where a force will be exerted on an object, opposite force of equal magnitude is
Newton's third law. Are you trying to explain by Newton's third law? When I derive this formula, did I use Newton's third law? Did I use Newton's third law or not? No. What did I use? What law? Newton second law. Okay, first you have to talk about write down when molecule collide with the wall. When molecule write down. When molecule collide with the wall, there is a change in momentum. There is a change in momentum of molecules. Means there is a force on the molecules. Or if you can mention a Newton's third law also. Okay, the molecule exert an equal. The molecules exert an equal exert. The molecule exerts an equal but opposite force on the wall.
So the law so useless.
Yeah, need to use the law. You're right.
Like this.
Okay, so first one is you have to talk about collide with the wall. Then after that you have to talk about change in momentum. Okay, so means they'll produce force. Then after that you have to talk about the opposite, same magnitude but opposite direction. Okay, molecule exert an equal but opposite force on the wall. The molecule exerts an equal but opposite force on the wall. An equal but opposite force with the wall. Okay, what is force? Pressure is what? Pressure is average force from the collision. Pressure is the average force per unit area on the wall. Per unit area on the wall. Okay, can you calculate the root mean square and give me the answer? Just derivation. The last one actually we've done before. Okay, try to calculate this.
1.51 times the power of 3.
Yeah, you are right. Okay, get the same thing. This one, the CMS. C1 square, C2 square, C4 square over 4. 1.51 times 10 to the power 3. Zing, can you get the same thing?
Can.
Can. Can you derive the change of momentum? What to write the change of momentum? This one C collide back become minus C. So what is this? Minus MC minus 2MC. Okay. Show this. How to show this? Can you show? What to write? Speed equal to distance over time. Distance is 2L. Speed is the C. So what is CT? T is 2L over C. Expression for change in momentum per second. How? What is this? Change in momentum per unit time. What is change in momentum per unit time? This one 2MC over 2L over C. So become what? CC C square over L. Time. Okay, this one can do. What is the total pressure? How to divide the last one? Total pressure equal to what? Pressure is what?
Also,
Force over area. Force come for what? Force come for many small force, right? Force is due to what? Change in momentum per unit time, right? What is the area?
2L².
L square. What is this is N and this is L square. What is F prime? F prime, this one, right? This is the change in momentum, mc square over L. So become nm c square over L cube. Nm c square over L cube. Are they using C? C or C? Okay, what is C square?
C². Oh,
Actually, this is U square
plus
plus what?
plus W square.
V square UVW V square of W square. And then when it's random, what happens to this field value? Random. They're the same one. So U square, V square, W square. Actually, this one's supposed to be only in one direction. It's talking about just one direction, right?
Yeah.
This is for one direction. But when you go to the three direction, then this one becomes 3U square. So the C square is 3U square. U square become 1/3 of C square. So this one, the original one, the pressure is okay. This one supposed you have to write M U square over L cube. So L cube is V, right? So it's PV and M U square. But U square is also 1/3 C square. So it's 1/3 mm C square. That's all for today. Congratulations. Finish it. Huh? Actually, this one is very misleading. You are not supposed to use C, because C is average value. You're supposed to just use U. Because U then is very clear. This U is just speed in one direction. But this C is a resultant speed. So by right, they need to use other thing. Otherwise, it's misleading. This one the book not very good. Correct or not? Ziying, do you understand or not? Can or not? Ziying, where are you?
Huh?
Huh?
Yeah, they
Yeah.
can.
Oh, okay, good. Okay, that's all. Next week we go to the other thing. First law of thermodynamics. Okay,
You, Mr. Chang.
bye bye.